Welcome, first 8th grade virtual session. I'm really tired today. I'm sure you guys are tired too. Starting the semester is always intense. So we are going to make this quick and hopefully useful. Kendrick. Of course, my dog always wants to play during virtual sessions. He thinks that when I'm speaking, it's like that I'm talking to him, I guess. I don't know, but he gets really excited. So I'm going to share my screen here. Okay, first thing first, most of you who are here either got the reminder, which I'm sorry, I sent it a little later than I intended to there. And some of you probably checked the calendar, right? So this is the best way to know what's going on, because I update this. I did change the time slightly, which I apologize for. The next one, we'll do it at 9 instead of 8:45. I was just remembering from last semester. For some reason, I picked 8:45, and I just went with it. So tomorrow, we also have a lab. That can be done in person at the school, or that can be virtual. We're going to be doing this really awesome lab where you get to spit in a cup, and we're going to put food coloring and stuff inside, and you're going to stir it up, and then you're going to see strands of your DNA. And we're going to learn about DNA, which is mostly a 7th grade topic, but is always a good topic to review, considering that it's important in basically every science. So no reason to not review it. So that's going to start tomorrow. The middle school lab starts at 9:30. We'll probably start the Zoom session at 10 a.m. So great question from Paige, is the lab mandatory? So this is what I'm going to ask of you guys this semester. I'm going to ask you to do 2 labs. That's it. So let's see how many I'm offering. There's 1, 2, 3, 4. There's 4 options of labs, and you only have to do 2 of them. So if tomorrow you're like, I already have something else to do, I don't want to go, whatever, that's fine. You're going to have 3 other opportunities. So the way that I did this in terms of turning stuff in, you can do all 4 of the labs if you want, and I'll give you extra credit, right, for participating in all of them. But otherwise, you only have to do 2. That way, you have some flexibility, and there's basically 1 a month. At the very bottom of modules in your course, there's this module called labs, and it just says lab turn in 1, lab turn in 2. And the due dates for these are, I think, in June, probably, because I put them at the end. Yeah, they're due for people June 12th. But if you do the lab now, right, you'll just come here. Yours will say submit, and you can submit your lab, and that will be your first lab. So since these will also be virtual sessions and they'll be recorded, that means that you can always watch the virtual session and do the lab in your own time and turn it in as well. So you don't have to be live to do it. It is more fun, right? This spitting in the cup one, the instructions are pretty simple. You could actually do it at home if you have the right stuff, which I'm going to send that after the session. So if you want to get some stuff. And Jonathan, thank you for being here. You're actually technically early because it did say 9 and I started early. So we'll say you're still early. Okay, so make sure you're checking the calendar. It does have all middle school stuff on here, right? So for example, next week, I'm going to be doing a virtual session with 7th grade. You don't attend that. And then on next Friday, I'm going to be doing a 6th grade virtual session in the afternoon. You don't attend that, right? So after today and tomorrow, we really don't have anything else for the whole month of February. Now, you guys know every Friday from 9:30 to 11:30, there is middle school lab. Me, Mr. Ling, and Miss Elaine are all there. So you can come, you can ask questions, you can do oral assessments, you can hang out, right? Sometimes there's like random fun stuff to do there. I do want to play this really fun game. Kendrick, come here. Called Chocolate River that doesn't actually involve chocolate, but it's fun. So hopefully if we don't have any more snow days, we'll get a Friday where we have an opportunity to do that. Okay, so check the calendar. That's what I'm trying to say. Other things, let's see. Let's go into the PowerPoint now. So I did organize this so I wouldn't just ramble, although I do enjoy rambling sometimes. Okay, so we're gonna review some of the stuff from the course. If you're new to the course, super helpful information. If you're returning to the course, still good to know. And then we're gonna talk about the periodic table. I just wanna show a couple interesting things about it, help you kind of learn how to use it a little bit. Even if you haven't gotten to those lessons yet, it's gonna help you when you get there. So first things first, we wanna know reviewing our course expectations, right? What are you supposed to do in the course? What's expected of you? And then we want to understand how the periodic table is organized and how to read one box for an element to determine the protons, neutrons, and electrons. So the periodic table tells us a lot of stuff. It tells us things generally about all the elements, and then also tells us about specific elements, certain things. All right, my dog's gonna chew on his plastic recycling toy. Give me a second. Cedric, you can't chew on this right now. It's too loud. Okay. So, my dog is a recycling lover. Like, he loves almond butter containers and plastic water bottles and like other like milk cartons. He just chews them. It's how he gets entertained. It's very weird. All right, course expectations. All right, this one is a dream that you'll attend at least one of the labs in person. Obviously, you don't have to, right? You can attend it virtually. But a real expectation is that 2 labs are turned in by the end of the semester. Like I said, we're gonna have 4. You have to do 2 of them. If you do all 4, then you'll get extra credit. Attend all the virtual sessions or let me know if you can't, right? I did have a few people email me saying I can't attend this one because of whatever reason. Great. You can always watch the recording, right? But it's better if you're live. Read the lessons. Seriously, read them. People aren't reading them. You know how I know when I'm grading your work, people are writing weird stuff that I'm like, where did you get this idea from? So make sure when you're looking at your Canvas calendar, right? And it says, let's see, it says maybe introduction to periodic table assignment is due. Don't just, if you click on the assignment, every single one, I'm telling you now, is gonna just say, submit your completed assignment, right? So you're gonna be like, oh, well, what's my assignment? You go into the lesson to find the assignment, but please actually look through the lesson, all right? I'm not asking you to like read every single word 90 times here, but look through the lesson. Oh, what's this? Okay, da da da. And after you're done going through every page, on the 3rd page, you will always find the assignment, right? Sometimes it's hard because they hide these links. They look like they blend in, but they're really a link to something, right? So if you have a hard time finding the link, please let me know, because I've had to play, like just move my mouse around until I found it, because sometimes it's really hidden. All right, so please make sure you're actually reading the lessons, because I've seen a few people who just are skipping straight to the assignment and they're not really putting their best work forward. Take notes, right? The reason why is if you're taking notes, then if you would like to redo a test or a quiz, you can just ask me and I will give you another attempt on it if you have notes. If you don't have notes, I'm not gonna let you retake it until you have notes. Also for the oral exams, you can use the notes. So when I'm asking you questions, you can have all your notes in front of you and you can look through them. The tests are also open notes, right? But it's hard, Kendrick, it's hard to use notes if you don't have notes. So make sure you have notes, because it's gonna be too time consuming to open lessons and try to find stuff. All right, and then make sure you're asking me questions. I don't know when you need help, right? So send me an email. I'm confused about this. I can't find this. I don't see this, etc. And I will answer you. I usually answer pretty quickly, and I will try to get your question answered as quickly as possible. All right, and then Canvas, I kind of already did that as I was talking, but just making sure that you really are going through the lesson, right? Modules is going to be the most important page in the course because that's where you're going to see everything that we have to do. Yours probably looks slightly different than mine, but because mine's a teacher version. You also are going to want to be going to the home page to check that calendar and make sure that we don't have something coming up. All right. So that's pretty much the expectations of the course, is that you're doing your best, you're asking me when you need help, you're actually reading the lessons, and that you're doing 2 labs. So now let's talk about actual science. Yay! Periodic table of elements. Okay, it's organized by atomic number, right? We're gonna look at a picture here in a second. This was a big deal. There were lots of people who tried to figure out how to organize the elements. And Mendeleev, right, was the guy who first came up with this concept of doing it by atomic number. The interesting thing is he didn't know all the elements, so there were lots of gaps and holes, right? And because of that, we actually knew which elements to look for. Our columns, or things that go up and down, right? Think of like a column in a house. Those are going to be elements that react or act similarly. They are like a group of friends. They have like similar interests and they do similar stuff. Our rows, right, so going across, are going to increase by atomic weight, which means they get heavier and heavier. So as you go across the row, you're going to be getting to heavier and heavier atoms. All right. Here's a beautiful, beautiful picture of the periodic table. I would recommend that you pick one that you like, a picture of the periodic table, and have it saved in your bookmarks because it is useful to reference it, right? Sometimes you just need to see where something is or its number or something like that. So we notice here that we have our numbers as we're going across the periodic table, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and keeps increasing. Sorry, my dog is just, can you just relax, please? Lay down. Okay. Anyways, so this one's color coordinated by the different families or groups. And some of the other ones are color coordinated in a different way, right? So you'll see a whole bunch of different kinds. Really, as long as you have the atomic number, the atomic mass, and the name of the element, that's pretty much all you need. Some of them will have more fancy stuff on there. So we're going to play a game, which is going to involve you needing to be looking at a periodic table. So if you want to look at that one that I was just looking at, it's called Colorful Periodic Table. I'm going to send it in the chat and you can go there. Otherwise, if you have your own periodic table that you want to look at, go ahead. We're going to play a little game. It's like a hunting on the periodic table game. I want you to answer these questions just quietly by yourself for a couple minutes, and then we'll have people say in the chat what they got. So looking at the table, you're going to decide which element is heavier, the atomic numbers of 3 elements that will react like neon, and 2 elements that will react like oxygen. And remember, those columns, those are going to be who react similarly. So columns are going up and down like columns of a house. All right, so I'm going to give you 2-3 minutes. We'll see. I'll give you 2 minutes to start. We'll see if that's enough time. So looking at the periodic table, try to answer these 4 questions here. All right. So even if you're not quite done, it's okay. We're going to, what does it mean when something reacts to another thing? Paige, killing it with the questions, killing it. So what it means is we're going to find out that elements have shells of electrons. I think I put one on one of these pages. Here we go. So we'll come back to this in a second, but if we're looking at this picture here of a carbon atom, we know that carbon, Kendrick, we know that carbon has 6 electrons, which we'll learn about why we know that in a second. And we're going to learn that elements have these shells of electrons. They're sort of like layers. And carbon can actually have 8 electrons in its second shell here, and it only has 4. And electrons want their shell to be full. Like that's their, elements want their shell to be full. That's their whole goal here. So carbon only has 4 and it really wants 8, right? So carbon will react and interact with other elements to try to fill its shell. So when we look at different compounds, we'll find out that carbon bonds with certain things or interacts with certain things because it helps fill its outer shell here so that it has 8 electrons. So basically, carbon is kind of unstable by itself. It would never actually, when carbon is found by itself in nature, it's actually bonded to itself a bunch of times. You would never just have one element of carbon just sitting there, right? Because it's basically like an unstable element that's like, I need my 4 electrons. So it's trying to find those electrons. So that's how we basically deal with reactions. We're going to dive into that a little bit. This year, you're going to learn a lot more about that in chemistry, and you'll learn all about, what those shells mean and why they exist and things like that. So that's a really great question, Paige. But that's how we know. It's really based on the number of electrons and the elements wanting to be stable. I hope that answers your question. It's a pretty hard question to answer, actually. Okay, so we'll go back to this. All right, so first question, which element is heavier, boron or iodine? What did you guys think for that one? Which one was heavier, boron or iodine? All right, we got lots of people saying iodine. So we'll come over here, take a little gander at the table. We found boron up here. Sometimes the hardest part of this is finding them, right? Especially when you get elements that you're like, what is that element? So boron has an atomic mass of 10.8. Okay, then we have iodine over here, atomic mass of 126, much heavier in terms of mass. Okay, awesome. Next question was, what is the atomic number of carbon, oxygen, and hydrogen? So what did we find out? We got carbon is 6. Oxygen is 8. This one might have been hard if you haven't done the lesson yet. You might have been like, what? What about hydrogen? Come on, hydrogen is the easiest. Hydrogen is number 1, right there. It's the first, lightest, tiniest element, and also found in almost everything that you guys interact with on a daily basis. Awesome, right? So all we did was look up here at these little numbers. Carbon was 6, oxygen was 8, and hydrogen was 1. All right, now these are the 2 hard ones here. Name 3 elements that will react like neon. So if we found neon, neon is on the far right of the periodic table. So I told you guys things in columns act the same, which means all these guys will act like neon. So you could have written helium, argon, krypton, xenon, radon, or, anyone want to try to pronounce that one? Unactium, something like that, right? That means that hasn't really been discovered and named yet. So these are actually a group in the periodic table that we call the noble gases. They don't react with anybody. So like I was talking about earlier when I was answering Paige's question, these guys have a full shell of electrons on the outside. They literally don't interact at all. You can mix them with anything and they won't react. They don't care. They have a perfect shell, right? And I think that's why they're called noble gases, because they're like better than everyone else, right? Like they're a king or something. So all these guys, all these helium, neon, argon, all these noble gases, they don't react at all. Which is pretty interesting. Then we have name 2 elements that will react like oxygen. So same concept here. We find oxygen. We see this row of, column. I always get column and row confused in my mind. Column, like a column of the house. See, I have to tell myself this. And we see sulfur, selenium, tellurium, a hard one for me to say, and polonium, right? So you could have written any of those 2. So all of these elements in this column with oxygen will react similarly to oxygen because they have the same number of electrons on the outside shell is the real reason why. But we're going to learn because they're in the same column. Okay. So what does each box tell us in the periodic table, right? We kind of did this slightly already, but we'll just be very clear about it here. So we have the name of the element, right? Carbon. We have the atomic number of the element, 6. We have the atomic mass, which is usually at the bottom. And you can tell the difference between the atomic mass and the atomic number because the mass is never going to be a perfect number usually, right? It'll have like a 0.00 something. It's going to be an estimate. In chemistry, you'll learn why that is. And then we'll also have the symbol, right? I didn't write that on here, but you'll see what symbols used. Carbon is a C. Sometimes there's other stuff, right? Some periodic tables go in with like 18 pieces of information in the box. We don't need that. These are the only things that we really need here. So why do we care about that, really, is what you should be asking, because we can look at the periodic table. All right. So I found this little graphic, which I think is from, yes, Paige, we're about to get to that, which I think is from a textbook, and it's actually pretty good here. So, oops, why won't this thing go up? All right, it says basically what I just said, right? That we have the atomic number, we have the atomic mass, we have the name and the symbol, right? The other interesting things that we want to know, though, is that the atomic number is going to be equal to the number of protons in the nucleus, as well as the number of electrons. So that number 6, which is being covered up by this ID thing, that means carbon has 6 electrons and 6 protons, right? The only time that that's going to be different is if you have a charged atom, which we're not going to talk about. So carbon has 6 protons, 6 electrons. We know that just from looking at this. So you could pick any element. You could just put your finger on the periodic table, and whatever number it is, that's going to tell you how many protons and electrons that atom has. Now, the atomic mass is the weighted averages of the masses of all the elements' isotopes, right? That's the technical definition. It's how much it weighs. So basically, we're going to round this number, and that's going to tell us protons plus neutrons, right? If you recall your basic atom structure here, the protons and neutrons are in the middle. They make a nucleus, and then the electrons float around in a cloud. So the mass is the protons plus the neutrons, right? Electrons technically have mass, but it's so small. It's like 0.000000, continuing the zeros for like 40 places, 1, right? So it's so small that we just neglect it. We just ignore it. But the protons and the neutrons, they have mass, right? So when they're added up together, that gives us our atomic mass. So just from looking at one box, we can determine lots of information. And I would definitely have this written down if you don't already. But the atomic number is going to be equal to the number of protons and the number of electrons. So for carbon, 6 is the atomic number. We have 6 protons, 6 electrons. Atomic mass is going to be equal to protons plus neutrons. So we can do some basic math here. I know, subtraction, everyone's favorite math. We can actually say, okay, so the atomic mass of carbon is 12, right? Because we're going to round it, is going to be equal to, we have 6 protons plus we don't know how many neutrons, right? And if we want to rewrite that, we'll say 12 minus 6 equals neutrons, which 12 minus 6 gives us how many neutrons?
6.
Yes, 6, thank you, right? So we have 6 neutrons. So some people get creeped out by carbon because it does have 6 electrons, 6 protons, 6 neutrons, right? It's got the 666 in there. Just throwing that out there. So we can do some little subtraction here to figure out how many neutrons are in the atom. So we also want to make sure that we remember that protons are positive, neutrons are neutral, and electrons are negative. That's going to become important because the protons and the electrons are equal. We have an equal number of positives and an equal number of negatives. So our atom is neutral, right? Neutrons, it doesn't matter how many you have. They're not going to change the charge. You could have 300 and it wouldn't matter, right? So that's important because we want these atoms to be neutral. We don't want them to have charges. Sometimes we do, but that's going to become much later. So we just did this, right? I did it on the other page, but I'll do it again just in case someone wasn't paying attention here. So basically, we're going to have 6 protons. That's given to us from the atomic number of 6. Neutrons, we know that the atomic mass minus the protons will equal the neutrons. So we know for carbon that we have 6 neutrons because we just solved that earlier. And then 6 electrons because protons and electrons are equal. All right. Carbon's an interesting one too because it's so nice and even and rounded. And it's actually, really, it's the element of life, guys. anything that's living contains carbon and is a carbon-based life. Which they're kind of thinking that maybe life in space might not be based on carbon, but might actually be based on something similar to carbon, right? So something in the same family as carbon could possibly produce life because of the properties of carbon. So there is a lot of talk about like a silicon-based life form, which is pretty interesting. All right, so you guys are gonna try now. We're gonna do oxygen, and then we're gonna do bismuth. I just picked a harder math one. So we're gonna round, right? So for oxygen, we're gonna round this atomic mass to 16. All right, so I'm gonna give you about a minute here, just looking at oxygen, figure out the protons, electrons, and neutrons. All right, all of the answers are 8, Paige says. Let's see if we agree with her. All right, well, first one, atomic number is 8. So we know already that we have 8 protons, 8 electrons. That was easy. Neutrons, we rounded our atomic mass, right? Remember, this is atomic mass minus protons. So we're gonna have 16 minus 8 equals 8 neutrons, right? So it seems like we're all agreeing here with Paige. Oops, I don't know what I'm doing. I have like text boxes everywhere. Yep, everybody says yes. Okay, so that one wasn't too bad, right? They're not all beautiful like that. We'll see with bismuth. All right, so bismuth. What even is bismuth? I don't know what it's used in actually. So looking at bismuth, figure out the protons, electrons, and neutrons. Can you use a calculator? Sure. Yeah, I don't care. I love calculators. I use my calculator for everything. Remember, we're going to round up here because it's 0.98. Awesome. Yep. Awesome. I'm seeing lots of people getting close here. Jonathan, you got 209. You got to subtract 83 from 209. So remember, we got to do atomic mass minus the protons. So the protons and electrons, you should just be able to go, oh, there they are, 83, plop them on there. But for the neutrons, that's when you have to round and do a subtraction, right? And then this is a good example of most elements where the neutrons are not at all similar to the protons and electrons, right? They're a very different number. And that's fine. They're not affecting anything except how much it weighs. Okay, so hopefully that helps you with that a little bit. Paige pointed out to me one of the videos in the lesson about this, they have a little typo where they say something wrong about how to calculate this. So be on the lookout for that, right? Because That's the way that you find the neutrons. Atomic mass minus protons. That's it. There's no other way to do it. All right, so this is the exit. We made it to the end. Woo. What you're going to do is you're going to pick an element on the periodic table that you have never heard of. And if you've heard of all of them, then pick one that you know a little bit about, like you don't know much about it. With that element, you're going to identify the number of protons, electrons, and neutrons and show your work, just because you could easily look that up, right? So actually try to calculate it, practice the skill of calculating it, and then research one thing that that element is used for, right? So like if I had picked bismuth, I would have put my protons, electrons, neutrons, and then I would have Googled it and read about what bismuth is used for and picked one thing to say. So you're going to email this to me by Friday at 3 p.m. And I'm basically just going to be keeping track of everybody's exits as they get turned in for virtual sessions, right? And that's going to go towards your grade at the end of the semester. All right, so hopefully this helped you guys understand a little bit more about kind of how the periodic table works generally. Notice we're doing some really basic stuff. There's a lot of complex stuff, right, that you're definitely going to be curious about. So feel free to ask about it, even if we're not going to talk about it in the course. I'm happy to explain it to you or give you a video or something to watch that will help explain. Otherwise, right, I'm going to be posting this PowerPoint. I won't let me exit. I'm going to be posting this PowerPoint. Actually, maybe I'll make, you know what I'll do? That's what I'm going to do. So it's easy to find. I'm going to make this labs and virtual sessions. And then you guys, oops, will be able to, really thing? You won't let me just scroll that up? You guys will be able to easily find this. So right now I'm going to create this content page of this virtual session. So virtual session on February, today's the 9th. Yes. Okay. So after I finish this recording, I'm going to come down here into this very last module. I'm going to post the PowerPoint and I'm going to post the recording. So you can always go back and look at the PowerPoint. Otherwise, I'm going to put up the exit one more time, just for a couple seconds here. If you need to quickly take a picture of it, take a screenshot, write it down so that you can work on it without having to wait for me to post that. And then while you guys are doing that, I'm actually going to write down who's here. Okay, so we have Antonio, Paige, Alexis, Landon, and Jonathan. Okay, awesome. All right, so I look forward to seeing your emails and seeing which element you picked. And otherwise, I will see you guys tomorrow, either virtually or in person, right, to see our DNA and to learn a little bit more about it. Jonathan, do you still want me to explain the exit one more time? Nope, you're good? Okay. All right, so yeah, email me if you guys have questions, and otherwise I will see a lot of you guys tomorrow. So I'm going to end the meeting now, and I'll see you tomorrow.